Okay, good morning. Let's start the session. There we go. Okay, so you know that we have lecture the next day you're coming into, right? So um, let's today's session we're going to go through many things. I want your undivided attention. And if you have any questions, stop me. Okay? Don't let me just go, because if I go further and then you linger on one topic, you're not going to go to the next. A quick pickup on what we've talked about last time, which has nothing to do with what we're going to talk about today. Just we were kind of doing some practice on different types of practice on encapsulating the C string into a class called str. We created it ourselves. And sorry. And so we're going to kind of go through what we have done over there. We went through creating a class to encapsulate a string. And we brought a character pointer inside this string, and we made it dynamically hold the C string and do all the dirty work we used to do using C string header file inside here so it can work with operators. We created different types of constructors for it to be able to set the data to whatever we want, to be able to set the data with a specific length, to be able to safely copy it around. So we added rule of 3 to it: copy constructor, assignment operator, and destructor. And also, we set it so it can easily work with legacy C string from C language, and overloaded different operators for it to see how it's going to work. And I'm sorry. Most important thing over here that many of you missed in the test is the print and read and write. Any type of I/O you are doing with I/O stream. If anybody ever tells you, I told you, if anybody ever else tells you to write and read from a class, you always flow the O stream through it. Many of you created void pointers. I didn't mind that much. I gave you the mark anyway, but and if I didn't give you the mark on that, contact me so I can fix your midterm mark. But when you overload reading and writing for I/O stream, always let the O stream object flow through your classes through the functions you have in the class. So print is that instance to do whatever printing is and then returning it out. And the same thing as read and so on and so forth. We will see soon why I told you that. And you'll see that that's going to make wonders when you're doing programming. And for overloading, again, many of you use friends. And I told you friends are for knife in a back. We don't use friends in C++. Friends are the worst thing you can use. Friends are only used for ownership. Remember, we talked about pets and yeah. So don't use friends. So, and many of you did for some reason. I don't know. Yeah, so an insertion extraction operator, if at any moment you want to create a helper function to do something with the class, always make sure that it uses the queries and the modifiers of the class. Queries and modifiers, what are they? What is a query? And changes the state. Yeah, so essentially methods that are constant are queries. Methods that are not constant are modifiers. Easy, simple, straightforward. So use those in your helper functions. Your helper function is not supposed to be friends of a class. The friend keyword, its side effect is to make one of its side effects is that you can actually make a function have full access to a class. We don't do that. We don't use that side effect. We use friend for what it is, which is ownership, what we're going to talk about later. And you're going to see it in a project probably. So that's that. That's what we have done with this string. And That was the last thing, I think around 3 weeks ago. Now, today we're going to talk about animals, okay? Why? Because I used this thing once and it just stuck. I use it all the time. It's a good way to teach the topic that we want to talk about now. So I want to encapsulate, and as you see, unlike other things that we have, this solution has several projects now. 1, 2, 3, so it has several projects that I'm going to go through one by one as I'm teaching it. So to actually fiddle with these things and start working with it to learn how it works, you have to right-click on a project and set it as Startup Project. Usually when you have several projects in a solution, one of them starts, right? One of them contains the main, if I can put it. So I put that one for the animal thingy, and I'm going to start with that. So I want to encapsulate an animal to see what an animal is to me. God, what am I like this today? So, and I have some utils thingy over there to do all my stuff. So that utils is loaded with lots of stuff. So you might want to take a look at it. I built that later a few semesters ago for something, and it has lots of stuff that you have in string header file. So you can use this utils for that. str, add str, compare different versions of it, different types of string copy, strn copy, strlen, str to find. So all the things that you have in C and C-type header file, like is alpha, is space, trim, lower key, all the things that you have in there. So if it's a good thing for character manipulation if you ever want to do one. So it's helpful. Anyways. Back in here, so to me, an animal is something that has a name, okay? And it's a very silly example. Don't think of like, but just let's assume that's what it is. So an animal is something that has a name, and it can act, move, and make a sound. These are the things an animal can do, okay? So I have two constructors over here, as you see. One is an argument constructor, and the other one is a default constructor. No argument constructor, which will be nameless by default. When you create a default value for an argument, you're essentially making it two methods, right? So no argument and one argument constructor. If I just create an animal, it's a nameless animal. If I give it a name, it's going to have a name. For absolutely no reason, I created rule of 3 over here, just for you to be able to play with it and see when it's being called. I'm going to remove it in next examples. So we don't need these things at all. The destructor I'm going to keep because we need to know what happens to the destructor when we are dealing with it. But these two things, please just note that it's there so you can put messages in it and play with it so you can practice on rule of 3 too. So what does an animal, so what is the implementation of an animal? The implementation of animal is something like this. So I create an animal, and you see over there, I say if debug. So in that utils thingy, I created a global variable called debug. When we set it to true, we print our messages. When we set it to false, the messages are not displayed. So you can run it with and without and see what the difference is actually. So creating an animal, I'm setting the name using the getter and getter. I have over here query and modifier. The name over here is a getter. It's a constant, returns the constant pointer to the name, so we cannot change it. And also we have over here a name that sets easy breezy, right? So we have these two things. I just saw spelling mistake. Copying. Okay. So, and I print different messages in everything. So in here I say if debug is say create, keep going like that together. Okay, so it kind of shows how things happen. And when we go down to the act and name, it's just printing messages close to what they have. So act like an animal, uh, uh, move like an animal, sound like an animal. Or we can say sound like, move like, so do something like this so we can actually see who is the person who, the animal who's doing that. So I'm just gonna add it over here. Okay, so when I run the program, but I have a main over here that shows different ways that an animal is being used. So I have show an animal over here that shows an animal, receives an animal by value, and returns an animal. And it's a very simple thing. I create an instance of the animal. Let's first set the debugging to false. So the debug, let it be false. All it does, it creates an animal called Fluffy. Remember, assignment at the moment of creation is a call to a one-argument constructor. It is not an assignment operator. And I know I keep sound like a broken record and keep telling it over and over, but I'm going to keep telling it until it kind of gets engraved into your brains. So I'm going to say I'm going to create an animal called open sound, and I'm going to the animal in the function, and I'm going to end my main. Running this program, we're going to see what happens. All right, so nothing happened. Why? Oh, I put F10 by mistake. Sorry, say F5. There you go. So it says act like Fluffy the animal, move like Fluffy the animal, sound like Fluffy the animal, showing Fluffy, and end of main, right? So it's very simple and straightforward. And as you see, it's like 4 lines of output. But what happens behind the scene is when you remove the debugging thingy, and you actually see how many things are being called for this thing, silly thing to happen. Now you see it's going to create Fluffy the animal, which, let me just bring it up over here like this so we can actually see what's going on. So at this stage, it is creating Fluffy the animal. That's line number 14, correct? Act, move, and sound are perfectly okay. But look at the show thingy when I say show animal. What happens? First, it's going to copy Fluffy the animal and set the name to Fluffy, right? So that's a copy constructor is being called when it's being passed by value. Very expensive thing. Then it's going to show the animal, which is showing the animal. Then it's going to copy it again for no reason. Why? Because I returned an animal by value again. Although it's not even being used, it's copying it into a nameless. So I created 2 objects and destroyed it for absolutely no reason. That's why we always pass stuff by reference. We don't pass it by value because it's just expensive. Are we okay with this? Are we okay? New people, are we okay? Are we okay? Are we okay with it? That was the thing. So a very simple thing, straightforward. Nothing extraordinary to go through. And that's it. So that's my animal. Are we okay with this? And now forget about copy construction, copy assignment. They're gone. We don't need to talk about it. Do whatever you want to do with it. We're going to move to the next stage. I have an animal, right? Now I want to have a cat. Not just an animal. I want to have a cat. Now, to have a cat, I already have an animal. Why do I need to reinvent the wheel from, why do I have to start from the beginning? Remember I told you when you want to make a motorcycle, you simply say a motorcycle is a bicycle that yada, yada, yada. So you can imagine that it has 2 wheels because a bicycle has 2 wheels. So you can get all this stuff from there. So a motorcycle essentially has everything that a bicycle has, but it removes some things and adds few things to make it better. That's what I want to do with my animal. I have an animal, now I want to have a cat. If I want to have a cat, how do I do that? How do I create a cat without creating all the things? Now, cat is an animal, we know that. What is an extra thing that a cat has that an animal doesn't have?
Extra life.
Yeah, extra life. It has number of lives, right? You read the notes forehand, right?
I do my homework.
Okay, so the difference between a cat and an animal is a cat has number of lives, okay? So when I create a cat, I need to say cat is an animal that yada, yada, yada. So is an or is a is written with scope resolution. Now, with a column. Now, I'll explain. So we know what our animal is. As you see, the over here called protected. We'll come to it. For now, just think that's public. Okay, so for now, public. Just think about it like that. I'll explain later on what it is. So I have everything that I had animal apart from those 2 things that because I don't want it to kind of clutter our teaching. Now I want to move this thing, and I want to create a cat out of this. So what I will say is that a cat is an, so column public means is a or is an, okay? So I say cat is an animal, and I put all the extra things that I want. I don't need to add a name anymore to it because animal has a name. So it comes with it, okay? And any other thing that I want to add to the animal to have a cat, is name and number of lives because you need to know the cat that you are getting, how many times it died already. So we want to know that. So, and if we don't specify number of lives, we want it to be 9. I don't think I did it over here, but let's say we could do it. Anyways. Remember shadowing in C language and early C++, we talked about shadowing. We said when in an inner scope, you define a variable with the same name of a variable that is in outer scope, it shadows it, which means it kind of hides it. And when you use it, it uses the inner one only. It's the same thing over here with the methods. If you create an identical method that the parent has, overwrite the parents, which means the act of the parents that was acting like an animal will not get executed, but this one will. If you think what the parent is doing is good enough and you don't need to implement it, just don't implement it. As you see, move is not implemented. So cat knows how to move because it's got it from its mother. It knows how actually it moves because the mother knows how to move. Now I'm going to tell you a little bit about mother thingy that we are saying. Very bad analogy over here that I'm going to tell that it's a mother and father. It's a very wrong thing to say in inheritance, but I'm just going to say it because everybody uses it. But then I'm going to correct myself. So I can make a sound, which means acting and sound. Act and sound are different with an animal, so I want that to be changed. But moving remains the same. And also it has an additional thing that it does, that is playing. Like cats play, but lions don't. I don't know. Let's just I'm just coming up with some nonsense stuff to teach. So that's essentially it. That's the gist of inheritance. You create a class that already exists. Now, talking about protected and private. Let's say that. Let's assume that we were very rich when I was young. We're not, but let's assume. Let's assume one of those rich kids that my father has a Bugatti or has a Porsche 911, okay? And also he has a Ford Festiva, okay? So My father wouldn't have never given me the Porsche 911 to go for a ride, right? Because, it's his favorite thing. But that Ford Festiva, everybody can use in the family. That's protected and private. Anything that is protected, the parent keeps it to itself. So when I said in the animal over here, setting name is protected, it means no one can set the animal's name other than animal itself, not even the children. Anything that is public, children can use. So, sorry. When I say protected, no one other than children can use setting the name. Okay? Public, they can. So protected one is the Ford Festiva thingy. So the private, the name itself, the child cannot touch. The private one is the Porsche 911. The protected one is the Ford Festiva that the family can use, but outside my neighbor cannot take it. I can. That's the protected one. Public, everybody can access. Okay? That's what it is. So when you see protected, it means public to the descendants. Okay? But private to outsiders. Private is private, as it was. Only the class can access it. Why did I do that? So the children can set their own names if they want to. But outsiders cannot change the name. They can only read the name. Okay? So name can be set by the object and its descendants and so on and so forth. Now about fatherhood and motherhood. That's an extremely bad analogy. My father and I are not I'm not inheriting anything from my father. My father and I are both instances of a human, or is made more specific, male human being. Me and my mother, the same thing. Me and my mother are both human, not from the same class. My mother had a function called birth that returned a human being. That was me. You follow? So let's say a query. So my mother had a query called birth that returned a human being by value, not by reference, because I'm a new person, right? So that's what it is. So that's the correct way of saying it. I am a mammal. That's inheritance. Okay? I'm a Homo erectus. That's inheritance. Inheritance says I'm a mammal, classifies me within certain things. I'm a male human being. I'm a male human that is a mammal. So this becomes inheritance. Inheritance is not different objects of the same thing. Okay? Although in real life that's what we call it, but that's an extremely bad analogy. Don't use it. Okay? So yeah, so that's one of the things that I actually used to do in interview when I used to hire research assistants. I used to actually ask that question. And yeah, anyways. So you know how people know it. So that's the reason I say when it's mother, I mean it's base class. Let's put it like this. In technical words, a base class and derived class is what we have, not fatherhood and motherhood. Okay? So that's that one. Yeah, so now let's see how the cat is going to act. So we're going to go to main. Now, as you see, I'm creating an animal called Coco. Okay? Then I'm creating a cat called Fluffy that has 5 lives. Died 4 times already. And then I'm going to create a cat called G that by default is going to have 9 lives, obviously. And this is the interesting thing. Remember I told you, please don't call me Mr. Solimanlu, okay? Don't call me by my parents' name. Why? Because if you refer to any class by their parents, by their base class as reference, although you can, but they forget who they were. My father was actually a teacher. He taught mechanics. So if you call me Mr. Solimanlu, I'm not going to teach you computers. I'm going to teach you mechanics. I'll forget who I am. You have to say Farda teach. If you say Farda teach, it's going to be object orientation. If you say Mr. Soleimanlu teach, it's going to be. And my sister is actually a teacher too. She teaches child psychology. And as you see, we both inherited teaching from my father. Again, bad analogy. Remember that? But if you refer to it, if you ask to my sister, Mrs. Soleimanlu teach, she's going to teach mechanics too. Okay? So be aware. Now in here, I am creating an animal reference to the cat G. And when I call that animal G thingy for act, you will see. So I call G act, it acts perfectly. But if I refer to it with the animal reference thingy, and you will see that it forgets that it's a cat. So let's go with it and see what happens. And debugging is true, so we see all the messages popping out. Or maybe we should just first, doesn't matter. So, and I'm going to go through implementation of it and tell you exactly how things are done. But for now, just let's take a look at it. Because there are some tricky things that we need to talk about. So when I actually, let me just remove these things so people ask questions over there I have. So the animal Coco is getting created. And as you see now, overriding the empty name of Fluffy. And then we'll say creating Fluffy the animal as a cat with 5 lives. So that's the constructor of that. Then we create G. When we create G, it's going to defaulting the animal, yada, yada, yada. Overriding, don't forget about these things. You'll see what they mean soon. Okay, you'll see what they mean soon. But just look at it over here that we are creating Garfield as defaulted with 9 lives. Now, when I create the reference, nothing is getting created, obviously. We know that for a fact. When I say G act playful Garfield the cat, because by default, I set the cat to be Garfield, okay? And then I'm going to say AG act, it's the same object with another reference. When I do that, it acts like an animal. So it forgets it was a cat. And then we're going to keep going, act and move and sound, everything and play, everything works perfectly. And the same thing, the reason that I brought an animal in here, to show you that, please put your logical hat on when you're thinking about this. Although things are inheriting from animal, but when you instantiate an animal, it's an animal. You don't need to think about, oh, there's a cat. No. When you create a base class by its own, it's the base class. There are no inheritance involved in here. Remember that, okay? So animal still acts exactly like an animal acted before, right? And it ends, and at the end, everything dies. Okay, so now let's look at the implementation. Actually, how do we implement the inheritance, and how does everything works with it? So let's go to cat.cpp. So as you see it, when you on the first 3 lines, the default constructor for the cat. When you create a base class and you don't mention how you want to create the parent will be defaulted. So when you are creating a child, when you are creating a derived class, and you instantiate it, if you do not specify and tell to the compiler how to create the base will be defaulted. Do we understand this? So in this case, although I'm saying cat like that, constructor would be called. And number of lives is instantiated, is initialized to 9. And then it calls all this stuff. So it calls the name and everything. Are we okay down to this point? If you want to, you can tell to the compiler how to instantiate the parent, how to instantiate the base class. So in this case, I'm saying the cat is created with the name and number of lives. Instantiate the base with the name. So it asks the compiler to invoke the 1-argument constructor of the parent, passing the name to it so the parent can get defaulted. And then the number of lives. And remember, the sequence of the remember what I called this thing? Initialization area. Remember, I said initialization area is the space between the constructor and the open curly bracket for the constructor. So this is the initialization area. Somebody actually found the real name for it. What is the real name for that thing? Anybody remembers? No? It actually has a name. I don't know what it is. I named it that way myself. There, if you actually go Google for initialization area in a constructor, I have no idea what you're talking about. Okay? But that is essentially the initialization stage of the constructor. So remember that the sequence of initialization must match the sequence of properties of the class. So if you have 3 attributes in the class and you want to initialize them over here, it should be the same order that's in the class. Otherwise, picky compilers will give you error. Okay? Visual C is very forgiving. Visual C++. But if you take it to thing, you're going to get an error. So obviously, the very first thing that has to get initialized is the base, and then the attributes. If I had 3 attributes, it would have been in the same order that we had. And now that we have that thing, when you are overriding, as I mentioned, when you override the parent's method with the exact same signature, it actually really override it. So it becomes inaccessible. Obviously, it's not accessible. It is. You can somehow access it, but we're not going to go through it now. But for now, just know that if you say act, the act of the child will be called. Obviously, you can completely override it. You can completely override like act, or you can reuse the code inside yours. So as you see over here, I'm saying make a sound, okay? But I'm going to say first call the sound of my base class. So you can reuse your base class and then do whatever you want. And therefore, you are reusing the code. If the code of the base is useful. If you don't want to use the code of the base, like I completely ignore it. Okay? Obviously, you can create methods that are completely new, and they don't even exist in a base class. And that's that. And the destructor is the same. It's created the same way. So now if I actually walk through this step by step, this is what happens. So that we know. I'm not going to go through it. But when the cat is actually getting instantiated, as you see, it goes to the constructor of the cat. And in here, I'm not actually, it goes to this constructor with 2 things. And because the name is passed to the animal, first it goes to the constructor of the animal, passes the name. Obviously, it initializes the name and passes the name as Fluffy, right? And then the name goes over here, and it prints the message, and then it comes out, goes back to the constructor of cat, and completes what it's supposed to do. And when I'm defaulting over here, because I did not mention it, I could easily over here, instead of naming Garfield, I could have done this. Take a look. Which is actually a preferred way. What did I do wrong? Stupid compiler. Okay. Oh, it's the, yeah. It is stupid compiler because it closes. I don't know whose suggestion in the development of the team was that when you put a double quote, close it. Why? Anyways, so as you see now, I'm not calling the 1R constructor of the base. You can do that. You can, like, and if in this one you wanted to, if you didn't mention the animal, the default constructor would have been called. Okay? And remember, if the base class doesn't have a default constructor, then you cannot even do that. You have to instantiate it properly. So this has the same effect. So this one, instead of the method name to be that is called, it actually goes to the base class and sets the base class. And then it does whatever it is needed. When act is happening, as you see, it goes to the act of the cat, and it has no access to the parent. But if I use the parent's reference, then it goes to the parent and forgets that it was a cat. Okay? And then it continues with the rest of the stuff. We know it, and there's no problem. You can always manually go back to something. Like, for example, in this C thingy, I can say C dot, like, for example, C dot animal sound. I can do that. I can literally, you can always use the base class name with the scope resolution to invoke the base classes method directly. That's your choice. But we don't do that. I rarely see such a thing happen. That means bad design. It means they didn't act properly, that I had to manually call the parents. When you inherit a class into another one, if you are supposed to be able to call the base class directly, you just overwrite it. You know, you don't call it directly. It doesn't make sense. But anyways, if you have to, that's the way to do it. But I'm just going to show it to you, but I'm not going to even put an example over here. Maybe should have. Wait, give me a second. Okay? Are we okay with this? Questions? Suggestions? Objections? So when inheritance happens, this is really what happens. When you have inheritance, so you have a base class, right? And this is your base. This is not your base class. This is your base class. Oh, come on. You can do it. This is your base class, okay? So that's the animal, okay? When you instantiate an animal, you see this. So when I say over here, animal A, this happens, right? When I create a cat, this is what happens. So when I actually create a cat, so if I say over here, cat, C, the compiler will first allocate a ginormous thing which can contain both of them. So it will allocate the size of the cat, which part of it would be the animal. Okay? And then it creates it that way. And that's why when you actually say, when you refer to a cat as an animal, it cannot be one anymore. It only sees the green thing inside, and it runs that one. So that's how it works. But that's going to be troublesome. I'll show you why. With references, life is beautiful. We have no problem. With references, let me just make sure that it runs. Here it runs. Set that startup. So this is the same thing that we had before, but I changed the main. Take a look at the main. You know that references or pointers are almost the same thing, right? So if I refer using the reference of animal, I should be able to do the same thing with the pointer of an animal. Problem, pointer can do dynamic memory allocation. So I can dynamically create a cat and hold it in a pointer of the animal, which is a very normal thing to do. You'll see soon. So let's say over here, if I want few people to dance, and I want to write a program for it, right? I'm going to write a human dot dance. And then when they dance, I want the ladies and the gentlemen all dance the way they are supposed to, right? But the problem is that if I do that, when I say human dance, then you don't really know which dance you want to do. You're going to lead or you're going to follow, okay? Anybody salsa? No? Anyways, so you know what I mean by anybody salsa, right? Okay. I don't mean sauce, I mean the dance. Okay. Anyway, so the dipping sauce. Anyway, so I create the animal point is this. Take a look. Everything is the way it's supposed to. We know that, which means it's going to forget it was a cat, which you're going to ask me a question that, why the heck you are creating a new cat when you cannot access any parts of it when you create an animal? And I will tell you that it's actually a problem doing that. So everything works exactly as I expect it to do. Which means, obviously, the cat's going to get created, right? And then, again, another cat's going to get created. That is Tom, but it's in an animal pointer. So Tom is not accessible in any way with a cat reference. Tom is only accessible using an animal pointer. And then I'm going to have an animal reference pointing to P. That is the Pepper the cat. Obviously, creating an animal Simba has nothing to do with anything. It has nothing to do with inheritance or anything. So P acts like a cat, right? The one with animal reference will not act like a cat. It will act like an animal. The one with the animal pointer will not act like a cat either. It acts like an animal. Are we okay with this? Are we okay with this? Any questions down to this point? Because I want to go to the troublesome of the thing. To the part that is troublesome. Now I want to delete the cat. Remember this? I said that when you refer to an animal, to a cat, by an animal reference or pointer, it forgets that it's a cat. When I delete, what's going to get deleted? The animal. What happens to the cat? Memory leak. That's bad. That's really bad. So now if when I run it, you'll see, as soon as I run it, you will see that the delete only calls the destructor of the animal, where the rest of the stuff, you see cat part is not deleted, and it's a leak, but the rest of the stuff, everything dies. So the Pepper, the cat, the destructor of the cat, and the destructor of the animal. Therefore, there is no memory leak. How can we fix this problem? It's actually extremely easy. It takes 3 seconds to fix that problem. How? First, you have to not close your Visual Studio because you need to because you need it to teach. And then let's go to the next one. Did I close it again? No. Okay. So that was my animal, right? Now, take a look. Take a look what I'm going to do. Take a look, take a look, take a look, take a look, take a look. Okay? In here, in front of the animal, I'm going to add one keyword. Virtual. As soon as you say virtual, you're telling to the compiler, hey, this is not the main thing. Look to see if there's a newer version. And run that one instead. So when you enter to an animal and you say delete, as soon as the compiler sees this, this is virtual. Let me see. I have to call the destructor of that one. Therefore, the destructor of cat will be called, and because cat contains everything, everything will be gone. Okay? You can do that to any function. I can tell to this function, hey, act is not the real thing. Sound is not the real thing. Which means act is upgradable. Sound is upgradable. Move is not. Which means if anybody refers to me as an animal, I'm going to move like an animal. I'm not going to change it. But if you tell me to act, I'm going to look to see if there is a new act. If I'm going to make a sound, I'm going to look to see if there's a new sound. And doing so, we can write beautiful programs like this. No, not beautiful program like this. I'm going to write the other one. Show you the next one. This is not the beautiful one. Well, anyway, so now if I'm running the exact same thing, so, oh, too early? Let me run it first. So which methods are virtual? Which methods are virtual now? Which methods are virtual? Act and sound and the destructor, correct? These three are virtual. Remember that. So now, let's run it. So the creation goes through, we don't care. And I think the debug is false, so it's not going to show any debugging. To distract us, first of all, when I create an animal, do I need to even care if something is virtual or not? You don't care if something is virtual. Everything is the same. So virtuality has no effect when there is no inheritance. Okay? And when you instantiate an animal, it's an animal. It's going to act like an animal as it was supposed to, so we don't need to even think about it. Now, you have inheritance. You have a cat, P, that holds a cat. Do you need to think about virtuals? No, because it's the same reference pointing to the same object. You have a cat, you are referring to as a cat. There is no virtuality to consider. The only time you should think about virtuality if when a child is called by their family name. When a derived class is be referred to or pointed to by the base class's pointer or reference. Now we're going to come to the next one. Again, no virtuality whatsoever. Cat's going to act like cat. Now I have a cat pointer pointing to a cat. Again, no difference whatsoever. Everything's going to work exactly as it is. I don't need to care. Now I have an animal pointer to a cat. Now I have to think about virtual. Is act virtual? Yes. So it's going to act like a cat. Is move virtual? No. So it's going to act like an animal. Is sound virtual? Yes. So it's going to act like a cat. It says meow. Don't worry. I put the meow at the beginning. Meow. Like a pepper animal. Anyway, so it does the meow. And if I have an animal pointer, it works the exact same way. Now, deleting C, do I need to care about virtual? No, because cat is a cat pointer pointing to a cat, everything is good. Deleting animal pointer, I need to care. So for this one, I'm going to stop it. Put a stop sign over here before the delete. Change the debugging to true. And run it one more time. So as you see, I do not need to care. As soon as it runs, it's removing Fluffy the cat and removing Fluffy the animal. So the destructor is called. Now I'm destroying the animal. Is the destructor virtual? Yes. So the destructor of the cat will be called. And therefore, you're going to have both parts deleted. OK? And let's say I have a function called tickle. So when I tickle, what's going to happen? An animal's going to get tickled. OK? And when it tickles, they're going to make a sound. So when you write a function, the base class is passed. You don't need to worry about what is being called because the first one is an animal. It's going to rat the animal is going to say ha-ha. If it's a cat, then cat's going to get ha-ha. OK? So it automatically chooses the right version. So I want you to pay attention to what I'm about to say right now. And it's extremely important. And if you don't do this in your test, on your workshops and stuff, I'll really be disappointed. Okay. From now till the day you die, when you write a C++ class, your destructors are always virtual. So if you submitted your milestone 1 and stuff like that, in milestone 2, in milestone 3, go back and make all your destructors virtual. We never have a non-virtual destructor. Why? Because a virtual destructor doesn't harm anything. It doesn't change how the code works. But if one day that class is inherited to another, you are not going to have memory leak. So remember, destructors are always virtual. Always, always, always. You should think of the syntax of a destructor as virtual, tilde, and the name of the class, not only the tilde thinking. OK? So remember that. That's extremely important. Are we OK down to this point? What is your native language? Hindi. What is your native language? Spanish. Hindi, Spanish, and I speak Azerbaijani. Hindi, Spanish, Azerbaijanian. We are all humans, right? If I say, if I want to implement awk for a human, how do I implement it? What do I write in that function? Hindi, Spanish, Azerbaijanian. But what do you put in it inside the function? What do you write inside the code of the function? The answer is, I don't know, because I don't know what's the language, right? Yet, it has to, India, right? It has to be inherited to an Indian for the Azerbaijani person. Extremely important to understand. Sometimes we have virtual functions that exist to implement. In the future, you say a human being is a person who can talk. So it needs to have a talk method. But the problem is that I cannot implement it
Yes, because
yet.
you know exactly
But how can you guarantee that the next get to a person with nationality actually to do? That's what we call a pure virtual method. Pure virtual methods are actions that classes must be able to do, but still we don't know how. Take a look at this. An animal can move, make sound, I don't know how, equal to 0. When you make method, put equals to 0 in front of it, you don't need to write a body for it anymore. It's not being implemented anymore, which makes the class animal an incomplete class, but compilable one. It compiles, but it's incomplete. You cannot instantiate it. If you want to instantiate an animal, how do you want it to make a sound? Compiler cannot instantiate a function that doesn't have a body. It cannot make it executable. So it becomes a wish list that you create, and you say anybody who wants to create an animal, that animal must make a sound to exist. Otherwise, they cannot. They become whatever. So we call it an abstract-based class. They become abstract. An abstract-based class is a class that has an idea on it, but not an action. You follow? It is extremely important to know these things when you are actually writing your base class. Sometimes in your base class, and that happens a lot, many times. When you create your class, you say, okay, this class should do this, but wait a minute, how? You keep thinking and thinking and thinking. It's not going to come out. You'll know that. And you see, okay, I have to implement these 2 different classes and implement this thing in 2 different ways. As soon as you think that, that's a pure virtual function. And pure virtual functions make your class abstract, which means animal is not instantiated anymore. It's not instantiable anymore, if that's the word. So if I come to the main over here, and as you see, I have a dog and a cat. And the cat makes a sound, and the dog makes a sound. Well, when I go to the implementation, the cat says meow, the dog says woof woof. Right? And in my main, what do? So I have a question. When I create a pointer to a class, am I instantiating the class? No. It's just a pointer to a class. It's an address, right? When I create a reference to a class, do I create a class? No. So you can still create pointers and references to abstract-based classes, but you cannot instantiate them. And that's our tool. That's our magic wand. That's what makes everything possible. Take a look at this. If I uncomment this animal thingy over there, I'll immediately get an error message saying object of abstract class animal is not allowed, which means animal cannot get instantiated. But dog, I can instantiate. I can even create a pointer and have and put the address of that I had over there. So this animal pointers point to different objects. And I simply one in a loop. And I'm going to say first one, make a sound. Second one, make a sound. Third one. And what happens is that because each object over here is aware on how to actually create the sound, obviously everything is created. As the first one is going to be a cat. The second one is going to be a dog. The third one is a cat. And the fourth one is a dog. Do you see an if statement over there? No. Am I calling functions with different thing differently? This is ultimate polymorphism. When the right version of the function is selected based on the object type. And that gives me goosebumps. This is amazing. It makes possibilities that is endless. You can do anything you want. Okay? Obviously, when I'm only up to 3, because I don't want to delete the one that is a dynamic one. So when they are deleted, because the destructors are virtual, automatically everything gonna get deleted perfectly as it's supposed to. They all, so the cat will be the cat's destructor, the dog will be the dog's destructor. Everything gets destroyed perfectly, and at the end, the automatic variables are deleted too, and that's that. Are we okay with this? Yes. Because you have an incomplete function in it. A function that doesn't have action. How can you create that? Take a look at, so yeah, I'm going to actually show it to you. So what happens is this. And another thing, 2 rules I have to do. 2 rules about the destructor before I answer your question. Remember I told you from now till the moment you die, you have to have a destructor. So from now till the moment you die, first, you must have a destructor, even if the destructor doesn't do anything. So if you have a class, and that class is not a class with resources, you don't need a destructor. Wrong, you do. You always put a destructor. If you don't need a destructor, the destructor to do anything for you, you do this. And you don't write any code for it. But you make it virtual. So if your class doesn't need a destructor, if it does need a destructor, then you put the destructor and implement it. So you write equal to default. If it doesn't need one, you write implement it and make it virtual. So must exist. A destructor must exist by default, and if you set it to default, which means compiler, create a destructor for me, but just make sure it's a virtual one. This is the safest way of writing. That's why it makes C++ language very, very dangerous with memory management, because these type of things, in compilation, it doesn't give you an error. But when you don't do it, your program 7, 8 years from now will have a memory leak without you knowing it, because somebody inherited a class out of your class to do some extra work, and your class didn't have a virtual destructor. And it hits the fan. Right? So these are important things you need to remember in your career. I'm not joking. Your programs are going to crash and have problems if you don't follow these things. This is extremely important to you, because it's not like I'm teaching to high school students how to think. You're going to go and work in, I don't know, IBM and Google and stuff like that. So of course, if you do once something like that, they're going to fire you behind. But make sure that you don't do that. Okay? Just remember. So that's that. Now, answer to your question, my friend. Where is the animal? Here's the animal. So, look at the left side and look at the right side. Do you see an implementation for sound? No, you don't have an implementation, but you have the function. How can you instantiate such a thing? How can you call? Because if you can create an object, you should be able to call its methods, right?
In the previous project, we didn't have sound.
We did have a sound, but it wasn't pure. it didn't have equal to 0. This is equal to 0 is the key. If you don't have this, you just have a virtual function, which means it does something and it's upgradable. But if you equal to 0, you don't know how it makes this class abstract base class. And we have a special type of abstract base class in object-oriented methodology, not in C++. In C++, an abstract base class is an abstract base class. Done. But in object-oriented methodology, a class that only has pure virtual method in it, we call it an interface. So if you hear interface, it means all you have are prototypes equal to 0 in it, and a default constructor that is set to default. That's it. You have no implementation whatsoever. And that's why I think it's milestone 2 that you are doing an interface. That's why you only have 2 days to do it, because you just have to write a class, write the prototypes, put equal to 0 for all of them. Done. Right? That's it. So that's that. I'll bring the code up for you to see how it is. So the interface, huh. What the heck? Sorry. So I'm going to modify that thing. It's not complete. I didn't think that I'm going to reach to this point, but I'm just going to show you over here what an animal looks like. Now take a look at this. Look at the animal. Forget about this. See the animal? Animal to me is something that can act, move, and make a sound. That's it. So, and it becomes an abstract base. To C++, this is no different with the animal we had before. They are both abstract-based classes. C++ doesn't distinguish the difference between the two. An abstract-based class is abstract-based class. Done. Okay? You cannot instantiate it. In object-oriented methodology, we call this an interface because it's an interface to use other things with. It doesn't do anything itself. Nothing. Yeah, nothing. Nothing. And remember, like you can actually, for an interface, I can actually do this. For an interface, I can say, this is next session's lecture that you're coming in for. But I'm just, when you are doing the milestone 2, this is what you need. Anyways, so in here, I'm going to say include IO stream. OK? Now look what I'm going to do. I'm going to say over here, O stream, actually, std OStream reference operator, the operator, so insertion operator, and at left side I'm going to put an std OStream reference OSTR, and at right side I'm going to have a const. Oh shoot, I cannot make it a constant. Damn it. I'm just going to say, for now I'm going to make it animal. I'm going to go home and fix it. The next, I'm going to come with a good one. But over here I'm going to say animal reference A. Okay? So, and for this one, I'm going to see in here, I don't even have a CPP file for animal. You see that? I don't even have a CPP file for animal because animal had no methods. But now I have to create a CPP file. I'll tell you what for that overload. So now in here, I'm going to create add new item. Animal.cpp. And in here, I'm going to include the animal. Why is it not? Oh, animal. Yeah. And I'm going to actually implement this. So in here, am I in a namespace? Yeah, I'm in stds. Well, seriously, namespace, stds. Okay, so now in here I can say a dot act and a dot move, whatever. Okay, return OSTR. So as you see in my reference, in my interface, as you see in my interface, I am even overloading the operator to do something that class specific way. Therefore, none of the descendants need to have that operator overload. Because every act will be virtual, every move will be virtual, and automatically the operator overload will act on the descendants perfectly. So by doing this, all the animals now know how to get printed on a screen. Does that make sense? All right? And that's abstract-based classes and interfaces. And we are done. Any questions? Yes? Mm-hmm. Yes, it's literally you can't, not technically, you can't. This way. Remember that thing that I drew? Remember this? You don't have abstract-based class, you can instantiate the animal. But assume that this doesn't exist. When you have an abstract-based class, the only way to instantiate them is to put it in the belly of their derived classes. So they get instantiated by instantiating the derived class. Why? Because now they will have implementation for the methods they didn't have any implementation for. Now they become complete. So you instantiate an abstract-based class, but only through instantiating their children. Does that make sense? All right. Any other question? Good question, actually. Thank you. Questions? Suggestions? Yes. I don't know. I don't know. Let's see what we're going to do. It doesn't make any difference, does it? It's going to be on whatever I teach. So, but if it's two, I'm going to let you do one of them at home. All right. Everybody's laughing. Woohoo! ChatGPT. Okay. Okay, what else? Questions? Yes, bud. Not or shadow. No. The, more time.
Acting animal and acting cat, it will act like an animal, not like cat.
No, if you show the cat, it will always act like a cat. That's perfect shadowing. Yeah, because I all the question. We go to milestone. Okay. No personal questions yet. Any general questions? I don't like that because I don't have access to your code. You give me your repository, I'll take it. Okay. Okay. Yes.
Have an abstract as a higher object, and you have a derived class from it. What happens if try to
Oh, you mean
like the things that you said that it's not practical, never do this, but if what happens if it's
so you're saying if I
the animal is abstract and you have a cat,
so if animal is abstract and I have a cat and I say over here c dot animal animal and I make which one was pure sound? Is that what you're saying?
yeah.
You can't. It doesn't exist. It doesn't exist. Okay, you cannot. But that because when you actually put what tilde, idiot. Seriously, let it go. Okay, so. Public yada, yada, animal yada 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 seven mention me. Okay? Because it doesn't exist. Yeah. We have runtime and compile time stuff. It's not runtime. Link time, let's put it that way. Because as we did in modules in IPC 144, we said that when you have functions in different things, you can put the body of the function in another module and put the prototype over here. And it compiled perfectly because it made sense, right? So that's what happens over here. So it compiles it, but when you want to actually link it, it tells you, okay, you tell me go to animal, it's there, but where is the body? Can't find it. Yeah. Quite frankly, I have never done that in my life, so I had to actually do it to answer you. I really did that. Because these are illogical things, like why you want to call the base when it's a pure virtual. But what happens, I don't know. Any other question before I go to the umpo little thingy? Any question? Any question one? Any question two? Thank you. I'm going to stop the recording. Please don't ask question after that. Are we okay?